Hey everyone, and welcome back to Talk Tensors. We're kicking off today's deep dive with a paper that's causing quite a stir, Truncated Consistency Models.
Oh, yeah, this one is really interesting.
It's all about upping the game in generative models.
Making them faster and more efficient, especially for creating images.
Like imagine being able to just snap your fingers and generate a photorealistic image.
Yeah, that's the dream, right?
Definitely.
Well, this paper is taking us a step closer.
Now, before we jump into the nitty-gritty of truncated consistency models, I think it'd be helpful to set the stage a bit.
Right, provide a little context.
For folks who might not be as familiar with the evolution of generative models.
Yeah, absolutely.
So maybe you can walk us through that history a bit. Like, where did it all begin?
Well, you got to go back to the OG generative models, the GANs and VAEs. They were revolutionary.
Oh, yeah, they were huge.
Groundbreaking, but they had their limitations.
They could be quite slow.
Yeah, especially as the complexity of the data increased.
Then came diffusion models.
Now, those were a game changer.
Amazing at creating realistic images.
But computationally, they were pretty expensive.
Kind of like a gas-guzzling supercar, powerful, but not very fuel efficient.
Exactly. And that's where consistency models came in.
Aiming for that same level of quality, but with a fraction of the processing power.
Right, more like an electric car, sleek, efficient, and still gets you where you need to go.
Okay, so consistency models were already a step in the right direction.
Yeah, they really were.
But what's so special about this truncated approach? What makes it stand out from the crowd?
Well, the thing is, previous consistency models were kind of trying to do two things at once.
Well,
Denoising, which is like cleaning up a noisy image,
got it.
and generating completely new images from scratch.
So like two sides of the same coin.
Yeah, and this paper is saying, hold on, maybe trying to master both is actually holding them back.
Interesting.
Like imagine trying to be a marathon runner and a power lifter at the same time.
Yeah, you might be decent at both, but...
You're not going to reach your full potential in either.
So focus is key.
Exactly. Instead of being a jack of all trades.
Become a master of one.
Right. And that's where the truncated part comes in.
Okay, so how do they achieve this focus? What's the secret sauce?
They came up with this really clever two-stage training process.
Ooh, 2 stages. Tell me more.
First, they train a standard consistency model, like laying the groundwork.
Gotcha. Build that solid foundation.
Exactly. This model learns how to handle both denoising and generation.
Okay.
But here's the key. They're carefully tracking how well the model is doing at denoising at each step.
So they're keeping tabs on its progress.
Yeah, like a detailed progress report.
I like that analogy.
Now, for stage 2, they bring in a fresh new consistency model.
Okay.
But this one is only trained on the later stages of the generation process.
The stages where the first model was already a rock star at denoising?
Precisely. They basically tell the new model, all right, you don't need to sweat the early stages, just focus on taking those already partially denoised images and turning them into masterpieces.
So the new model gets a head start.
Yeah, it doesn't have to waste time learning the basics of denoising. It can jump right into the artistry.
I see. So it's all about efficiency.
And specialization.
But how do they ensure this new model, with all its artistic freedom, doesn't go off the rails and start creating something completely out there?
That's a good question, and they've got a clever solution for that, too.
I'm all ears.
They use the output from the first model as a guide for the second one.
So it's like having an experienced artist looking over your shoulder.
Exactly. Providing feedback and keeping you on track.
That makes sense.
It's like taking an art student who's learned the fundamentals and then sending them to study with a master painter to really hone their unique style.
I love that analogy. So stage 1 builds a solid foundation.
And stage 2 refines and specializes.
So did it work? Did this specialization actually lead to better results?
Oh, the results are really quite impressive.
Spill the tea. What happened?
These truncated consistency models, or TCMs as they're called,
Catchy name.
they not only generated higher quality images on standard data sets,
Oh, wow.
but they even outperformed some models that were twice their size.
Wait, really? That's incredible.
It's like David taking down Goliath in the AI world.
That's a huge win for the little guy.
Yeah.
But how do they actually measure this improvement?
I mean, did they just eyeball it and say, yep, this one looks better?
Or is there a more scientific approach here?
They introduced a new metric called denoising FID, or DFID for short.
EFID. Yeah.
Don't worry too much about the technical jargon.
We'll spare our listeners the headache.
But essentially, it allowed them to see how the models were shifting their focus over time.
So, like a window into the model's mind.
You could say that, and what they found was really interesting.
What they find?
The TCMs actually got worse at denoising.
Really?
Yeah, that initial cleanup stage.
Ah, why is that?
Because they were putting all their energy into becoming generation experts.
Fascinating. So it's like they were saying, we don't need to be good at cleaning up anymore. We're going to generate such stunning images right from the start that there's nothing to clean up.
Exactly. And that's what's so exciting about this paper.
It's not just a new model.
It's a whole new way of thinking about AI training.
Like, what if instead of trying to create these all-encompassing AI models that can do it all,
We focus on training specialists.
right? Could this lead to breakthroughs in other areas of AI beyond just image generation?
Absolutely. And we're already seeing this trend in other fields like natural language processing.
Yeah, models designed for specific tasks like translation or writing different kinds of creative content are really starting to shine.
They're outperforming those generic do-it-all language models.
Exactly. And that's where things get really interesting.
If specializing AI models can lead to such impressive results in image generation,
What other possibilities might this unlock?
could we train AI to compose different genres of music
Or write code in specific programming languages?
or even design personalized medical treatments?
Now, those are some mind-blowing possibilities. But before we get too carried away with the future of specialized AI,
Right.
let's take a closer look at how this truncated training approach actually works.
Yeah, let's break down the nuts and bolts of this two-stage process.
Perfect. So walk us through it. How do they actually truncate the consistency model?
Well, it's actually pretty clever. In the first stage, remember they train a regular consistency model, like we talked about, laying the foundation.
Right. Getting those basics down.
This model learns how to handle both the denoising and the generation.
Uh-huh.
But here's the key. They carefully track how well the model performs at denoising at each step of the process.
So it's like they're keeping a detailed progress report on the model's denoising abilities.
Exactly. Now for stage 2,
Okay, what happens in stage 2?
they bring in a fresh new consistency model.
Brand new.
But this one is only trained on the later steps of the generation process. The steps where the first model was already really good at denoising,
Oh, I see.
they essentially tell the new model, okay, you don't need to worry about the early stages.
Got it.
Just focus on taking those already partially denoised images
Yeah.
and turning them into masterpieces.
So the new model gets a head start.
Right.
It doesn't have to waste time learning the basics.
It can jump right into the advanced artistry.
Now, to make sure this new model doesn't go off the rails and start creating something completely bizarre,
Right. It could get a little crazy.
they use the output from the first model as a guide,
Exactly. It's like having an experienced artist looking over your shoulder,
keeping you on track.
giving you feedback.
Okay, so stage 1 is about building that solid foundation.
And stage 2 is about refining and specializing.
It's like taking an art student who's learned the fundamentals
And then sending them off to, like, study with a master painter.
to hone their unique style.
Yeah, that's a great analogy.
And the results speak for themselves, right?
Oh, yeah, for sure.
This specialized training approach,
It led to significant improvements in the image quality,
even beating out much larger, more complex models.
which is really saying something.
It's like proving that sometimes less is more.
It really is.
By focusing on a specific skill set,
You can achieve a whole other level.
these truncated models were able to achieve a level of mastery that those general-purpose models just couldn't match.
And this has huge implications for the future of AI, right?
Definitely.
It suggests that specialization could be the key to unlocking even greater capabilities.
In other areas beyond just image generation,
Exactly.
imagine AI models that are experts in writing different genres of music,
Wow.
designing complex architectural structures,
Right, that'd be cool.
or even developing personalized medical treatments.
That would really revolutionize things.
It's a future where AI isn't just a general-purpose tool,
Yeah.
but a collection of specialized experts, each contributing their unique skills to solve complex problems.
Like building the ultimate AI dream team. And it raises some fascinating questions about how we design and train these specialized AI agents.
Right.
How do we determine the optimal level of specialization?
Yeah.
How do we prevent these models from becoming too narrow in their focus?
It's like finding that sweet spot.
These are all challenges that researchers are actively exploring.
For sure. It's an exciting time to be following the field of AI.
Absolutely.
But before we dive too deep into those questions,
Yeah.
let's shift gears a bit and explore some of the novel notions that this paper has inspired.
I like that segment, novel notions.
Those what-if ideas that keep us up at night.
It's the fun part.
All right, hit me with your most mind-bending thought. What have you been pondering?
Well, we've been talking about specialization, right? We've been talking about specialization, right? But what if we took that concept even further?
Further, how much further can we go?
What if instead of training AI to be an expert in a single task, we trained it to be an expert in learning how to become an expert?
Whoa, hold on, you're blowing my mind here.
It's like meta-expertise.
So instead of teaching AI to paint,
we'd teach it to be the ultimate art teacher.
Able to guide any student to mastery.
No matter their style or medium.
That's incredible. Imagine an AI that could analyze any task.
Break it down into its core components.
And then design a personalized training program.
To help another AI master that skill.
It's like an AI training coach, a sensei for the digital world.
Exactly.
So we're not just creating AI artists or musicians.
You're creating AI that can create other AIs.
That's next level stuff, but wouldn't that require an incredibly sophisticated AI?
One that understands nuances of learning styles, skill sets, even creative processes.
It seems like we're a long way off from that kind of AI sensei.
We might be closer than you think. Researchers are already exploring meta-learning techniques.
Though really?
Where AI systems learn how to learn.
So AI learning about learning.
This paper on truncated consistency models could actually be a stepping stone in that direction.
Interesting. How so?
Showing us that focused training can lead to remarkable gains in efficiency and performance.
So instead of training AI to be a painter, a musician, a writer,
we train it to be a master learner, able to adapt to any creative domain.
It's like unlocking a whole new level of AI potential.
It opens up a world of possibilities for AI and human collaboration.
Imagine a world where AI can not only assist us in creative endeavors,
it can also help us learn and grow.
Pushing the boundaries of human potential.
It's a future where AI isn't just a tool,
but a partner in exploration and discovery.
That's a beautiful way to put it.
It's a future that's both exciting and a little daunting. But that's the beauty of AI research, isn't it?
Absolutely. It constantly challenges our assumptions.
And forces us to reimagine what's possible.
And papers like this one on truncated consistency models.
They're paving the way for those future breakthroughs.
For sure.
Well, I think our brains are officially full of novel notions for one episode.
Mine too.
For our listeners who want to explore the technical details of truncated consistency models,
all the nitty-gritty,
you can find a link to the full paper in the show notes.
Definitely check it out.
And if you have any thoughts or mind-bending ideas inspired by this paper, we'd love to hear them.
Join the conversation in the comments.
Until next time, keep exploring the ever-evolving world of machine learning.
And remember, the future of AI is a journey we're all taking together.
See you next time.